Hi everyone, in this lecture I'm going to continue the 11th chapter, input, output, and exception handling in Java. In this lecture we focus on exceptions and errors and how to throw and catch exceptions in Java. Exception handling in Java can be thought of as a mechanism to um, detect exceptions and errors and handle them. Basically, you can think of exception handling as a flexible mechanism for passing control from the point of error detection to a handler that can deal with the error properly. So when you detect an error condition, you throw an exception object to signal an exceptional condition. Exception is basically a class, and you throw an object of that class, and somewhere else in the code that object will be caught by a catch block. As an example of an exceptional condition, you can think of when someone tries to withdraw too much money from a bank account. Uh, in this case, we need to throw an illegal argument exception. How can we do it? Basically, you need to first create an object of exception. The class that we create an object of is an illegal argument exception. That's a subclass of exception class. We'll see the inheritance tree of exceptions later in this lecture. And then this exception is equal to new illegal argument exception. This is the name of the class. With a constructor that gets a string amount exceeds balance, and this string will be printed out on the screen so that the user knows what happens. The user will be notified what kind of exception has occurred. And after you creating this exception, you simply throw it. You throw the exception. The important point here is that when an exception is thrown, the method terminates immediately and the execution continues with an exception handler. Basically, throwing an exception terminates the normal control flow of the program, and the program or the execution of the program continues with an exception handler. So the first syntax that you need to remember is this: throw an exception object. For example, if an exceptional condition happens, like amount is greater than balance, you want to withdraw more amount than the actual balance of a bank account, you simply say throw new illegal argument exception with an appropriate constructor, which is an appropriate message that will notify user of the type of exception that has happened. If this exceptional condition doesn't happen, then you subtract balance by the amount that is going to be withdrawn from the bank account. So here is a part of the hierarchy of exception classes. It is important to remember some parts of it, especially the top branches. Exception and error are two implementation of interface throwable. So throwable is an interface. Basically, every class that implements throwable uh, can be thrown as an exception or error in Java. And we have two different implementations, either an exception or an error. In this case, we focus on exception. Exception is a superclass that has three subclasses: IO exception, class not found exception, and runtime exception. We have multiple IO exceptions, for example, file not found exception, malformat URL exception, or unknown host exception. These are a few examples. you can, if you don't see this diagram clearly in the in the video, you can check out the slides that I uploaded on Canvas. And then the runtime exceptions is the superclass for a number of subclasses for a number of runtime exceptions. For example, arithmetic exception when you divide a number by 0, or class cast exception, illegal argument exception, index out of bound exception, no such element exception, or null pointer exception. These are, some exception subclasses that you can create a object uh, from them, and you can instantiate an object of exception uh, of these types of exceptions. So basically, these are all runtime exceptions, and these are all IO exceptions. It's important to know that there's a rule in Java that says every exception should be handled somewhere in your program. You need to place the statements that can cause an exception inside the try block and the handler inside the catch clause. So as you see in this piece of code, we have a try block that contains the statements that may cause an exception, and we have two catch clauses. The first catch clause catches the exceptions with type IO exception, and the second catch clause catches exceptions that has type number format exception. For example, if if the scanner constructor which wants to scan a file with a file name fails to do that, for example, because the file doesn't exist, with a file with a specific file name doesn't exist, then an IO exception will be thrown in this try block and is caught by this clause, and this statement will be executed as an appropriate handler of the IO exception that has occurred. Or, for example, if the input that we read or we scan here from the file doesn't um, represent a valid integer, then the integer that parse int will fail to parse an integer, and it throws a number format exception, and that number format exception is caught here in this clause, in this catch clause. So there are two statements that may cause exceptions, and both of them are caught in the following catch clauses. But both the statements are inside the try block, and they are caught after the try block. So as I said in the previous slide, there are a number of exceptions that may be thrown in the try block. One of them was when the scanner constructor throws a file not found exception because the file name doesn't represent an existing file on the disk. And another one is, for example, when a scanner.next throws a no such element exception, for example, maybe because we have reached to the end of the file, and a scanner.next throws a no such element exception. Or we have another possibility for throwing an exception in that try block, which was integer.parseInt method that can throw a number format exception. So it's important to know that if any of these exceptions is actually thrown, then the rest of the instructions in the try block are skipped and will not be executed. So in this slide, we want to see what happens when each one of those three exceptions are thrown in the previous slide. If a file not found exception is thrown, then the catch clause for the IO exception is executed, the first catch clause, because file not found exception is a descendant of IO exception. In the hierarchy chart that we saw in a few slides back, we saw that file not found exception is a subclass of IO exception. Therefore, if a file not found exception is thrown, IO exception will catch it. If you want to handle a file not found exception differently from other IO exceptions, you can place another catch clause before the clause for an IO exception. So immediately after try block and before the catch clause for IO exception, you can add a different catch clause for file not found exception. This way you can tailor the way you want to handle file not found exceptions, and you handle it differently from all other IO exceptions. If a number format exception occurs, for example, the number has a different format and parse int cannot has a wrong format, and the parse int cannot parse that number, then the second catch clause is executed in the code that I showed you a few slides back. And it's important to know that if a no such element exception is thrown, there is no appropriate catch clauses uh, after that to catch that exception. So the exception remains thrown until it is caught by another try block. Maybe this try block is inside a different try block which is larger than that and contains this try block, and the exception that is thrown will be caught by another try block. So another syntax that you need to remember for exceptions is the try block and the catch clauses. As you see, the try block will contain a number of statements that may throw some exceptions, and after try block we have a number of catch clauses that each one of them catches a specific type of exception. And it's important to know that you need to place more specific exceptions before more general ones. For example, in this piece of code, we want to put two different catch clauses. One is IO exception, the other is exception. IO exception is a subclass of exception. So exception is a more general one, and IO exception is a more specific one. It's important to note that this specific one must come before the more general one. Otherwise, if you place this more general before the more specific one, then it is logically invalid, because any IO exception will be caught by the first catch block, which is type exception. So it's important to note that the more specific one, in this case IO exception, must come before the more general one, exception. So it's important to know that each catch clause contains a handler, and the example that we showed had a very simple handler that just informed the user of the problem, but it's better that inside the handler you give a second chance to the user so that the user can correct uh, his or her fault. And when you throw an exception, you can provide your own message string. As you saw, we can have a string inside the constructor of illegal argument exception and provide a more detailed reason for that exception. For example, we say amount exceeds balance, or you can even put the balance amount and amount and the balance amount and the value of the amount that you're going to withdraw from the account, so that the user has a better idea of why the exception has thrown. Also, it is very important that you only catch those exceptions that you can handle, because if you cannot handle it, it's better to throw it and give the control to the to the object or to the class that has a more uh, uh, has a more extensive information about the exception, and has more authority to take care of the exception and handle the exception. So in this slide, I'm going to show you a classification of Java exceptions. The exceptions can fall into three different categories. Internal errors are the first category that are reported by descendants of the type error. If you remember, the error was one of the two main classes that implements throwable interface. As an example of this kind of exceptions, you can think of out of memory error. Another category of exceptions are descendants of runtime exception. These exceptions happen in runtime, and while we are running the program, not at the compile time. They are also called unchecked exceptions. And as an example, you can think of index out of bound exception or illegal argument exception, which indicate errors in your code. The last category is all other exceptions, which we call them checked exceptions. For example, IO exception, it indicates that something has gone wrong for some external reason beyond your control, beyond the control of the programmer. For example, IO exception happens, for example, when no file is found, or for example, you don't have permission to access a file, or inside the file there are some illegal formatting that you cannot parse. So let's talk about the difference between checked and unchecked exceptions. Checked exceptions are due to external circumstances that the program cannot prevent. The compiler checks that your program handles these exceptions. So although you're not the cause of this exception and they are caused by external circumstances, but the compiler checks whether you have handled them or not, and if not, the compiler asks you to handle it before letting you to run the program. That's why we call them checked exceptions. But the unchecked exceptions are your fault, the programmer's fault. The compiler doesn't check whether you handle an unchecked exception. We will see different examples in the following slides. So let's talk about a feature, an interesting feature in Java that allows you to throw an exception in a method and catch it in another method. So as a simple scenario, you can handle the checked exceptions in the same method that throws it. For example, you have a try block, and after that you have a catch clause that basically catches the exception that may be thrown in this try block. This is a simple scenario. Now in this slide, I'm going to show you a different scenario, a more complicated scenario that uses a keyword in Java, which is throws. Let's see how it works. Often the current method cannot handle the exception. Why? Because it doesn't have access to sufficient information, or it doesn't have the authority to do something about the exception and handle the exception. So in these cases, you simply tell the compiler that you're aware of the exception that may be thrown, but you cannot handle it, so you throw it out of the method so that someone else or some other method can handle that exception. So you want the method to terminate if the exception occurs, and you simply add a throws clause to the method header. So after the signature of the method, you simply write throws file not found exception. So it throws an exception with this specific type so that some other method in some other part of the program that has more information and authority to handle this specific exception. So the throws clause signals to the caller of the method that it may encounter a file not found exception. Now the caller has also two options. The first option is to handle the exception. The second option is to declare the exception may be thrown again. So you may call a method, the method may throw an exception, and then you can throw the exception that you receive from the calling method again. So the exception can be thrown twice or maybe 3 times or 4 times, because the caller has two options, either to handle the exception or to declare the exception may be thrown. At the end of this chain, after throwing it maybe 1, 2, or 3 times, the last method must handle the exception. So as I said before, the exception must be handled somewhere in the program. So we have a policy of throw early and catch late. We throw an exception as soon as the problem is detected, but we catch it only when the problem can be handled. We have no rush to handle an exception when there's no sufficient information or authority in the method that we are in. So if we cannot handle it, we simply throw it so someone else, some other method with a higher authority and more information can handle it. So here is the syntax for a throws clause that you need to remember. As you see, you can throw more than one exception class after the signature of the method. If you want to list more than one, you need to separate them with comma. And as you see, you must specify all the checked exceptions that the method may throw, but you can also list some unchecked exceptions, but it's not necessary. But you may also list some unchecked exceptions like this one, number format exception. So far we have seen the try block and the catch clause. There's another clause which we call it the finally clause. So once a try block is entered, the statements in a finally clause are guaranteed to be executed whether or not an exception is thrown. Usually we use the statements in finally clause for cleanup purposes. For example, consider this piece of code that we created a new print writer for a file, and we start writing data into the file, but maybe for some reason we throw an exception, and we need to close the file before interrupting this writing process to the file. So we simply say in the finally clause, we add a finally clause, and we simply say out.close, so that in the case that an exception happens and the execution of the code is interrupted by the exception, we close the file before we get out of this method, so that the file is closed after running this method, no matter whether an exception happens or not. So here is the syntax of finally clause. After the try, you can have a finally clause that, this code is always executed even if an exception occurs. It's important to know that you can design your own exception types, but you need to extend it. You need to extend the exception or extend the runtime exception so that the type that you're defining or designing be a part of that hierarchy that we showed at the beginning of the lecture. So, for example, you can design an exception called insufficient fund exception, and you throw it when an amount to withdraw from the bank account exceeds the current balance. So you can say if the amount is greater than balance, then throw a new insufficient fund exception with the following message: withdraw of amount exceeds the balance of balance. So that this exception would have a constructor that gets a message as its input and maybe prints out the message for the user so that the user knows what happens that this exception is thrown. And then obviously the insufficient fund exception is an unchecked exception, so the program could have avoided it by calling the get balance first and making sure that you have sufficient balance before before withdrawing from the bank account, and it extends the runtime exception or one of its subclasses. So in this slide, I'm going to show you how to construct that specific exception for your own program. In fact, how to design a new exception type. For example, the exception type was called insufficient fund exception. Here is how you define it. You have to say public class insufficient fund exception that extends the runtime exception, and it has two constructors. The first constructor has no input parameter and it does nothing. The second one, which gets a message, a string message as its input parameter, basically handles the exception by printing out the message. And how can we do this? You can simply call the super message, which is the superclass constructor. The superclass is runtime exception, so it basically executes the constructor of runtime exception with this message that it gets from the input parameter. So when the exception is caught, its message string can be retrieved by calling the getMessage method. The getMessage method is implemented in all the classes that implement throwable interface. So since runtime exception implements getMessage, and insufficient funds exception extends runtime exception, therefore insufficient fund exception inherits the implementation of getMessage method, and you can use this method to retrieve the message string.